The Cybertruck is expected to undergo a minimum 5% price reduction by around 2025 or 2026, aligning with Tesla's aim to produce 300,000 to 400,000 units annually. Presently, progress is on track to reach 40,000 to 80,000 units in 2024, with Gigatexas pushing to meet targets within a tight timeframe. Have you witnessed the production process of the Cybertruck's stainless steel body during the Sandy Munro tour? It's not just the Gigapress that's impressive. Tesla's ownership of various exclusive machines for each manufacturing stage in crafting the Cybertruck materials is equally remarkable. Elon Musk's successful resolution of production machinery challenges holds a significant weight, determining 60% of whether the Cybertruck's manufacturing process encounters difficulties. So what notable advancements can we anticipate for the Cybertruck in 2024? Let's find out in today's episode of Tesla Car World. Welcome back to our channel. Before we begin, we hope that you and your family will be healthy, happy, and successful in all endeavors during the new year. Now let's get started with today's content.
As you can see with all the equipment, we're ready to roll at like high volume. Now it's just like, how do we ramp, go slow, get quality.
The number of Cybertrucks that Tesla can produce will be demonstrated through a process involving at least 20 fundamental steps, executed by 70% exclusive modern machinery. Moreover, Musk has frequently addressed the production schedule for the year of 2024. Meanwhile, there have been numerous positive reviews and impressive feedback on the Foundation series, with a handful already delivered to early customers and a large number set to be delivered in the coming months. What are your thoughts on the total cost of $120,000 for this variant? Shifting beyond the Foundation series, the standard versions are also set to begin widespread deliveries soon, as Tesla showcases impressive momentum in production speed. What's the secret behind Musk's ability to launch a significant number of Cybertrucks in 2024? In our previous discussions, we delved into the reasons behind the Cybertruck's gradual transition into a production challenge due to the demands of the HFS alloy, which is 5 times more durable than conventional steel, boasting a hardness of 90 HRB. This necessitates a dedicated production line unique to this model, a seemingly daunting task that Tesla has successfully resolved. So how did Tesla manage to miraculously eliminate 60% of the bottlenecks associated with the production of stainless steel material? Sandy Munro provided a comprehensive account of the Cybertruck's body production, highlighting that nearly 100% of its construction involves stainless steel. During his visits to Tesla's Texas facility, the intricate molding of the vehicle's 45-karat bulletproof steel panels has garnered significant interest, unveiling a wealth of astonishing details about Tesla's most controversial vehicle.
To something called a leveler. All it's really doing is it's got a bunch of work rolls and they're moving up and down, and they're flattening the part.
Initially, there was an assumption, perhaps shared by many, that Tesla received pre-flattened stainless steel sheets, neatly stacked and ready for use at Giga Austin. However, the reality was quite different. The steel arrived in large, heavy rolls with 2 distinct thicknesses available, 1.8mm for the doors and 1.4mm for the Cybertruck's sails and hoods. Tesla engineers have made significant strides, reducing the initial stainless steel thickness from 3mm to an impressive 1.4mm, while maintaining exceptional flexibility and retaining its bulletproof strength. Upon arrival, the stainless steel undergoes a meticulous process, secured onto a round column and passed through a leveler or straightener to ensure a flat, even surface. At the laser booth, 2 parallel laser beams precisely cut these sheets into the Cybertruck's hood structure with remarkable precision, achieving cutting accuracies of up to 30 microns, far surpassing the 1mm capability of similar machines. These cutting-edge machines, developed through a collaborative effort between Tesla and the supplier Schuler, not only cut the steel but also transport the finished sheets to their designed parts, eliminating the need for welding within Tesla's manufacturing process. This advanced stainless steel processing technology represents a significant leap in production efficiency and precision. But to what extent does Tesla prioritize the inspection of final product quality?
So we'll take the part, put it on here. It's just a nice fancy 2D light scanner. And what it does is it compares the cat that we're cutting to in relation to what we're actually measuring.
Following precise laser cutting, the steel plates are meticulously stacked to prevent any potential scratches, then moved to the measurement system, employing a 2D light scanner. It's remarkable how methodical the Texas engineers are at each stage to craft the Cybertruck to the highest of standards. Musk's investment in expensive top-tier machinery specifically for the pickup illustrates his profound dedication to the project. This machinery serves as an optical comparator, meticulously verifying the dimensions of the cut stainless steel against Tesla's predetermined standards. The team has achieved exceptional levels of accuracy, measuring in microns. Nevertheless, this doesn't imply laxity. Engineers continuously conduct routine checks to ensure the measurement machine maintains a robust CPK, or Process Capability Index, and upholds precise repeatability standards. How attentive has Tesla been to the Cybertruck's door frames?
Yeah. Well, we went through a lot, aluminum bronze coating here in the inserts to make sure that we don't get those drag marks on the stainless itself. And I think we have the world's fastest, first, only high-speed A-class surface stainless press.
We're making 10 strokes per minute over here.
Beyond ensuring precise sizing, Tesla's engineers have delved into comprehensive research on molding the doors, particularly emphasizing the front doors. They've heightened the front door mold, highlighting the utilization of an aluminum bronze coating on the pads to prevent any marks on the stainless steel. Tesla proudly boasts the possession of the world's sole and fastest Class A high-speed stainless steel press, capable of executing 10 strokes per minute. We're aware that the manufacturer is consistently exploring lubricants and other elements to optimize the stamping process. At a rate of 10 strokes per minute, the process can generate roughly 600 parts within an hour. Discussions about the durability of the molds coated with aluminum bronze have surfaced, eliminating a lifespan of up to 50 to 100 stamping cycles before necessitating rework. This press is instrumental in producing various components, including the rear door, hood, 4 doors, and headlight box. Engineers have emphasized the paramount importance of upholding high-quality standards, striving for flawless technical specifications at a level currently surpassing 80, while they continuously endeavor for enhancement. In the production process, the material undergoes heating to 900 degrees Celsius across 21 furnaces. Following heat treatment, the material is pressed between the upper and lower molds for a duration of 6 to 8 seconds, with water flowing through each mold to cool the part. Remarkably, Giga Texas achieves a production rate of 144 inner parts and 150 outer parts hourly, boasting 100% operational efficiency. Tesla places significant emphasis on employing robots and automated systems to streamline and amplify efficiency throughout the production process. An essential technique in stainless steel processing is air bending, allowing steel sheets to bend primarily using air, achieving a curvature between 5mm to 8, contingent upon whether it's for the inside or outside. Engineers at Tesla stress the necessity of maintaining this curvature range to prevent any risk of cracking. Following shaping and refining, robots and laser machines unite the inner and outer parts through welding, meticulously minimizing excessive weld seams. Undoubtedly, numerous stages might have been overlooked, yet the highlighted processes aim to offer an insightful glimpse into Tesla's accomplishments, an advancement surpassing initial expectations. Musk indicated during Tesla's third quarter of 2023 earnings conference that it might take roughly 18 months for the Cybertruck to become a substantial positive cash flow generator for Tesla. This suggests that substantial profits may start materializing around late 2025 once the challenges in the pickup truck's production are resolved. Consequently, 2024 is anticipated to mark the year when Tesla recuperates its investments and begins significantly amplifying its earnings. However, after examining each phase of Cybertruck production at the Texas factory, guided by Monroe's insightful observations, it appears Musk is aiming to expedite this timeline to just 8 months, significantly shorter than the previously stated 18-month period. 3 prominent U.S. banks, Goldman Sachs, Morgan Stanley, and UBS, have offered production forecasts for Tesla's off-road vehicles, presenting a significant shift between 2024 and 2025. Their estimates suggest 48,500 vehicles in production for 2024, with Musk potentially achieving production figures spanning from 78,000 to 230,000 vehicles in 2025. Why is the 4680 battery the key element of Cybertruck and not the stainless steel frame? We're not entirely sure how you view the 4680 battery technology, but for us, it's a key factor that enhances the value of the Cybertruck. Tesla has gained recognition for its groundbreaking 4680 battery technology, which plays a pivotal role in innovating the entire EV sector. However, like any innovation, it's facing initial challenges, particularly in scaling up production, which Tesla is currently navigating. The question arises, is Tesla perhaps moving too swiftly, considering a shift away from the 4680 battery technology for the Cybertruck? Reflecting on the time when Tesla unveiled the controversial Cybertruck back in 2019, the 4680 battery emerged as a seemingly miraculous solution, significantly mitigating criticism surrounding the pickup. Its potential and superior power compared to the 2170 or LFP batteries were widely acknowledged. Musk highlighted that these larger cells not only offer increased energy for the truck, but also serve as durable components of its frame. This innovative design substantially reduces the necessity for welds, ultimately leading to decreased production costs. According to undisclosed sources cited by Reuters, Tesla has yet to implement the dry coating process for the 4680 cells at the required scale to meet production objectives. These sources indicated that while the dry coating procedure for positive electrode cells proceeds without major issues, Tesla faces difficulties in replicating a similar approach for the negative electrode. The reality is that even if the manufacturer conquers this hurdle, Tesla faces a challenge in ramping up battery production swiftly enough. Despite Elon Musk's expressed ambition to sustain Cybertruck production at 250,000 units annually, the current output seems to be around 2,000 trucks per month. A crucial issue arises. Tesla struggles to generate an adequate supply of 4680 battery cells even after addressing the stainless steel processing phase. For context, each Cybertruck necessitates 1,360 cells, and Tesla's monthly production only covers approximately 2,000 trucks. On average, about 10 million 4680 cells are produced every 4 months, equating to around 2,500 cells released per month by Tesla. Tesla is actively refining the tri-coating technology, working to resolve challenges in the process. This isn't just a concern for prospective Cybertruck owners who might encounter extended wait times, it could also impact current owners relying on older battery technology of potentially lower quality. The 4680 battery technology involves a Teflon adhesive that needs to be moisture-free to effectively bind lithium, nickel, and other elements together. However, Tesla faced a challenge with the mixing process, generating excessive heat, causing the Teflon adhesive to melt. During the initial stages of each new production line, Tesla had to discard 30 to 50% of the products, and this high rate persisted for several months. Previously, the battery production process had an error rate of about 5%, and Tesla is diligently working to reduce the error rate for the 4680 cells to below 20%, or ideally even lower. Tesla is notorious for keeping production details under wraps. Initially, there were whispers that the dry-coated 4680 batteries were slated for use in the Model Y. However, Tesla has opted to integrate its tried and tested Panasonic 2170 batteries into the Model Y for now. Some industry speculators suggest that Tesla might be reserving the 4680 batteries solely for the Cybertruck or perhaps the Juniper project for the Model Y in the future, once larger quantities are achieved by the year's end. For the time being, the focus remains on exclusive use for the pickup. While perfecting the 4680 battery technology, Tesla is exploring methods to modify the battery's chemical composition to enhance energy density. Integrating the 4680 battery into the Model Y could prompt Tesla to develop a new, more premium variant akin to the Model Y Plaid, potentially sporting a higher price tag. Drew Buglino, Senior Vice President of Engineering at Tesla, outlined plans to construct 8 production lines for the 4680 at Gigafactory, Texas. As of now, Tesla has only 2 production lines, but is swiftly moving to surpass the record of 20 million cells by October. Tesla faces a significant challenge by concurrently venturing into multiple innovations with the Cybertruck. Introducing numerous new technologies adds strain to a system that isn't yet fully ready for deployment. The company is striving to scale up while developing components and equipment exemplified by the 4680 batteries and the low-voltage 48-volt system. In addition to battery production hurdles, Tesla is in negotiations with Mexico to establish a new factory for 4680 battery and Cybertruck production. Reports from the governor of Nuevo León suggest that Tesla has been adjusting its plans, expanding the proposed factory size threefold. These ongoing changes may indicate that Tesla encountered challenges in meticulously preparing for the Cybertruck's production and its crucial components. For Tesla to meet its target of 250,000 Cybertrucks annually, each requiring 1,360 cells, they would need to produce 1 million 4680 battery cells daily. Presently, the Austin factory produces roughly 10 million cells every 4 months. Equivalently, equating to approximately 32.5 million cells cells per year, far below the 340 million needed to achieve Musk's ambitious Cybertruck goal. Nonetheless, Musk's incremental approach, applying the Kaizen philosophy to set and achieve small goals, might pave the way to reach this target soon. Beyond the Cybertruck, Tesla intends to implement the more efficient 4680 battery cells in the upcoming $25,000 Tesla Model 2. Expected to debut around early 2025, this compact Tesla is poised to be a robust competitor due to its price tag below $30,000. The success of the Cybertruck and Tesla's upcoming electric models hinges on the ability to produce the necessary batteries. Without a steady battery supply, they could face an uphill battle against competitors, even with more competitive pricing. The current cost of the Cybertruck remains relatively high, and if Tesla struggles to match the production volumes of rival vehicles, the future of electric trucks might face uncertainty. Thus, while Tesla has made significant strides in streamlining stainless steel manufacturing, investing heavily in ramping up 4680 battery production becomes pivotal. It's crucial to emphasize that without sufficient batteries, the prospect of delivering electric vehicles becomes challenging. Tesla's ability to expand battery production or find innovative methods to accelerate mass production within a confined scale holds immense significance. This approach could be a transformative tool, optimizing resources and reducing the time needed for scaling up. Speculations about Tesla introducing incentive programs of up to 5% to boost Cybertruck interest hint at their strategy to navigate these challenges. As Tesla overcomes hurdles in stainless steel manufacturing, focusing on the final steps of scaling battery production brings them closer to Musk's ambitious goal of 250,000 Cybertrucks annually, a milestone that seems within reach. These improvements will fortify Tesla's position, ensuring they meet their ambitious production goals while maintaining quality and innovation in the electric vehicle market. What improvements do you think Tesla should prioritize in their Cybertruck production line? Your insights are appreciated. We trust that this video brought you a sense of relaxation. If it did, we'd appreciate your support. Kindly hit that like button and consider subscribing to our channel to join the Tesla car world community. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time, so for that, we thank you and we hope to see you again next time. Until then, stay safe and have fun.